In this video, we are going to introduce you to Insight Multizone. This is an advanced yet user-friendly well modeling tool that can be used for a variety of engineering tasks. This includes optimization of your completion before exporting an upscaled valve to a reservoir simulator. We can quickly compare different types of completions. We can study the effects of permeability and productivity variations along the well, and even the effects of water and gas breakthrough. To begin, navigate to the multi-zone application icon and select it. Next, proceed by clicking on Create a New Project. We are taken to the Zone Template Definition tab. Here we can see all the upscaled valves that we have created and stored. We can click on View button to get even more details about the upscaled valve. All of the parameters used to create this valve are included here, like wellbore geometry, fluid properties, and pressures. We will check off the 4mm ICD valve that we created in a previous video. Press the Select Rows button. The valve will now be available for us to use, and we can move on to the next panel by clicking Next. In this tab, we will outline some important parameters of our well, like the number of zones, the productivity, reservoir pressure, and the amount of water, gas, and oil in each zone. Select the 4mm ICD from the Templates tab, set the number of zones to 8, and click Add New Zones. This well will be 800 meters long since each zone is 100 meters. Remember that we specified the length of the zone when we created the valve in the multi-run. We will set a random productivity in each zone for this example. Later in the video, I will show you how we can automatically optimize the ICD nozzle sizes in each zone to create an even inflow to the well. We will set the reservoir pressure for each zone to 200 bar and set the water and gas fractions for each zone to 0, so it only produces oil. Now that we have everything entered here, we will click Next to specify the fluid properties. We will select Use Zone Template Parameters to retrieve the fluid properties associated with this valve, and you can see that the properties are automatically retrieved. Click Next to move on to the Solver section. In the Solver tab, you can keep most of the default options. The mesh size specifies the element length, dt is the time step in seconds, and time step specifies the total number of time steps in the simulation. Select a location to save the simulation. Click Next to move on to the boundary conditions. Here we will set the pressure outlet, the temperature, and the wall roughness of the base pipe. For this example, we will use 180 bar, which gives a drawdown of 20 bar, and we will set the temperature to 100 Celsius. We have green check marks on all of our tabs, so we can click the Run Simulation button. In the dashboard, we can view a variety of results. In this plot, we can see that this well produces 2,630 meters cubed per day, and the flow rate in the base pipe gradually decreases in the direction of the toe of the well. We can see how much oil is produced from each zone in this plot. It varies from 272 in Zone 1 to 374 in Zone 6. These variations are mostly due to the variable productivity along the well. Here we can also inspect the temperature along the base pipe. The temperature is calculated from the energy balance in the system. Now, if we wanted to even out the inflow along the well, we can go back to the Wellbore Definitions tab, check the Automatic Valve Strength Optimization box, then apply uniform influx to each zone, and rerun the simulation. The optimization is finished, and we can see that the production in each zone has converged to 330 cubic meters per day. This was achieved by increasing the flow in low permeability zones and decreasing it in high permeability zones. If we go to the Wellbore Definitions tab, we can view how many 4mm ICDs we need in each zone to achieve this inflow. With that, we'll conclude this tutorial on the multi-zone section of the Insight software. For more information, take a look at our website at flowprodynamics.com or send an email to insight@flowprodynamics.com. Thank you for watching.